Section 3.8 is on direct, inverse, and joint variation. And these terms come from when we look at the relationship, which is a ratio of two or more quantities or numbers. There are these three types of relationships exist: direct, inverse, and joint. So we can look at these things graphically and we can look at them algebraically. For example, we have the equation y equals kx to the n. So y equals x to the n, or x to an exponent, is an exponential function that looks like the graph on the right here. K is what's called a constant of variation, so it's just a constant or a number. And what's happening in this graph is as x is getting bigger and bigger and bigger this way, y is also getting larger and larger and larger this way. So we can say this is a direct variation. And what a direct variation means is that as one variable gets bigger, the other one also gets bigger, or as one gets smaller, the other also gets smaller. So direct variation, or directly proportional, means that y varies directly as x to the n if there is some non-zero constant k such that y equals k to the k times x to the n. So what this means, again, is that as x gets bigger, y also gets bigger and bigger. So as x increases, y increases. As x decreases, y decreases. So they change at the same together. So let's say you have two equations that are directly proportional. y1 equals k times x to the 1n, and y2 equals the same constant k times x to the n 2. So what I'm going to do here is I'm going to manipulate these equations so that I get two proportions. So I'm going to solve them both for k. K equals y1 over x to the n1, and in this equation k equals y2 over x to the n2. Because k is the same in both equations, we have the proportion y1 equals x1 to the n equal to y2 over x2 to the n, substituting them in for each other because they both equal k. If I cross multiply, I get the equation y1 times x2 to the n equals y2 x1 to the n. So both of these relations can be used to find missing values. So here's an example of how we use direct variation. If you know y varies directly as x, and y equals 6 when x equals 11, now we want to find y when x equals 3. So in both of these direct variations, k is going to be the same thing. So what we want to start to do is figure out what k is, and then when we have two equations, we can use that to find the missing value for y. So there's two methods that we can use to solve this. The first method is going to be to write an equation and solve it. So the first equation, well, we're going to look at the basic equation y equals k x to the n. And I'm going to use my values that I know for my first equation here, 6 and 11. Y varies directly as x. When y is 6, x is 11. So I'm going to have 6 for y, k, and x to the n is 11. I'm going to divide both sides by 11. K equals 6 over 11. Now I can use this value for k and plug it in for the other equation. So now I know that y varies directly as x when k is 6 to the 11th. Now I know x is 3 and I'm looking for y. So I'm going to have 6 over the 11. X to the n is 3. Multiplying across the top, that's 18 over 11. So when x is 3, y is 18 over 11. Method 2 is to set up a proportion and solve the proportion. And solve. So we're going to end up with the same solution. This is just a different method to approach it. So we can approach it. N in this instance is 1, so we can drop our exponent here. So we can say, using our proportion that we found here, y1 over x1 equals y2 over x2. In our situation here, y1 equals 6, x1 equals 11, y2 is what we're looking for, and x2 equals 3. So you see in this case, we've already eliminated k from the equation, so we aren't having to look for k. We can just plug numbers into our proportion here. So we can say 6 over 11 equals y over 3. We can cross multiply. That'll give us 18y equals 11. Divide both sides by 18. And what did I do wrong? Oh, y should be here. Divide both sides by 11, and we have 18 over 11. So same answer, just different methods to do. I don't have a preference which one you use. That is entirely up to you, whatever you are more comfortable. So here's a problem for you to try. If y varies directly as x and y equals 9 when x is negative 15, find y when x is 21. So either method you can choose. You should get, when everything is reduced, your solution should be negative 63 over 5. So see if you can get that answer. So after direct variation, we have inverse variation, which is the same as inversely proportional. So this means that x and y are changing in opposite directions. So as x is getting bigger, y is getting smaller. As x is getting smaller, y is getting bigger. So y varies directly or inversely as x to the n if there is some non-zero constant k such that x to the n y equals k. So again, k cannot be 0 because then you're eliminating the proportion. But what this means is as x gets bigger, y gets smaller, or as x gets smaller, y gets bigger. So they vary opposite of each other. And we have two equations. K equals x1, y1, k equals x2, y2. So in the same sense, we can x can have an exponent, or we can say it's 1 for now. Because these are both equal, they both equal the same constant k, I can say x1 times y1 equals x2 times y2. And if I want to set up a ratio here, I can divide both sides, both variables to one side of the equation. So I can have y1 over y2 equals x2 over x1. So either of these equations can also be used in inverse proportions. So here's an example. If y varies inversely as x and y equals 10 when x equals 20, find x when y equals 16. So we have the same concept here, except we're just using a different equation. This time x and y are on the same side of the equation as opposed to opposite sides. So method 1 again is set up an equation and solve. So I'm going to have, again, my exponent is just 1, so x and y equals k. My first variables, x is 20 when y is 10. That gives me k equal to 200. Now I can use that k in my second equation, x2, y2 equals k. I know my y2 is 16, I'm looking for my x2. So just plugging in what I know, k is 200. Divide both sides by 200. And x is going to be 200 over 16. When I reduce that, that's 25 over 2. The second method again is to use the proportion that we have here and eliminate k altogether. So this is going to say y1 was 10, y2 was 16, equal to x2 is what we're looking for, over x1, which is 20. Cross multiply, you get 200 equals 16 over x squared, or I'm sorry, x2, divide by 16, and when you reduce it, you should get 25 over 2. So again, whichever method you like better, please use that and try this problem. When y varies inversely as x, y is 4. When x is 12, find y when x is 5. When you do this, either method, you should get 48 over 5. So please try that and check your answer. Okay, the third type of variation is joint variation. This is very similar to direct variation. You'll notice the equation is exactly the same, except instead of just y depending on just x, it depends on more variables. So in this case, we're going to depend on x and z. So y varies directly as x to the n and z to the n if there is some non-zero constant k such that y equals k, x to the n, z to the n, where x and z are not zero. So notice it's the same equation as direct variation with just a z variable added in. So I have a little typo here. This should say the volume V of a cone varies jointly as the square of the radius of the base r and the height h. So in this case, volume is our y. That's what is depending on two other variables. The other variables are the radius squared and the height. Find the equation of joint variation if the volume is 285, r is 4, and h is 17. So here's what we want to do. The first thing we want to do is write an equation of joint variation. We said v was what things, the other two variables, it depends on the other two variables. K is our constant. Our x to the n is r squared. That's the first thing we depend on. The other thing we depend on is the height. So our equation for a cone is volume equals k x squared times h. And then we just want to start plugging in what we know. I know the volume is 285. I don't know what k is. I know r is 4, so r squared is 16. And I know h is 17. So this is going to give me 285 equals k times 272. Divide both sides by 272. And k equals 285 over 272. That cannot be reduced, but as a decimal it is 1.05. So now that I find k, all I want to do is rewrite this equation here with k plugged in. So my equation of joint variation, volume equals 1.05 times r squared h. So this is my joint variation for the volume of a cone. So I would like you to try this next one. We are looking for the area of a trapezoid. It varies jointly as height and the sum of the bases. So y is going to be your area, and then the two things it depends jointly on are height and the sum of the bases, b1 plus b2. See if you can find the equation of joint variation if the area is 48, the height is 8, base 1 is 5 inches, and base 2 is 7 inches. You should get that k equals 1/2, and that your joint variation equation is 1/2 h b1 plus b2. So I've pretty much given you the tools to solve that already, so please try that and make sure you get the correct answer. Okay, thank you for listening, and I will see you in class tomorrow, and we will do a lot more super fun problems. All right, see you later.